This tutorial will help you complete the 5 assignments on homework number 9 on DeltaMath.com. Let's get started with the first topic, which is arithmetic on polynomial expressions. So for this, you're going to be using a lot of substitution. So the actual question here is to subtract the letter C minus 3D. And C is a polynomial expression, and D is a polynomial expression. So we're going to substitute them into the place of the letters C and D. So C is 2x squared plus 5x minus 1. And then we're going to subtract 3 times the D expression, which is x minus 1. So there's no math to do here in the first polynomial, so I'm going to remove the parentheses. But I am going to distribute this minus 3 to both of those terms, giving me a minus 3x and a plus 3. Be careful with your sign right here. Combine like terms. And then type it into this answer section down here. In order to do that, you are going to need to press the Shift 6 button, and that raises you up to the exponent power. And if you didn't want to use that, you could always open this keyboard here and use the exponent button right here like that. I'm going to use my basic calculator keyboard here. Plus 2x, plus 2. Submit my answer. Well, let's see. Fantastic. Let's clear my annotations here and let's try another problem. This time I want 2c minus b. So as I'm substituting here, I'm going to get 2 times the c quantity, which is 1 plus p squared plus 3p, and then minus the b quantity, which is 2p plus 6p squared. So this one I need to be careful because I'm distributing this invisible negative 1. So over here I'm going to get 2 plus 2p squared plus 6p after I distribute this. And then over here I'm getting minus 2p minus 6p squared. So again, I'm going to put my answer in standard form, which means I'm going to start with my p squared terms. So negative 4p squared plus 4p, and it looks like I just have the one constant 2. Type that answer in here. Negative 4p shift 6 gets me my exponent, and then I arrow to the right one time. Plus 2. Let's see. Fantastic. Clear that writing. Do you guys feel like you need to see one more? Let's see. What's this problem look like? 2c plus 3b. These all look pretty similar. I think they're pretty similar. If you need more help than this, come to Extra Help on Tuesday or Wednesday. All right, let's take a look at our second topic, multiplying with fractional coefficients. All right, for this one here, you're basically just multiplying these binomials together, and it's just telling you that your answer will be a trinomial. Again, write it in simplest form. So let's get started here. We're going to have 1/3 x minus 5 times 3/5 x minus 4/5. And 1/3 times 3/5 is 3/15 x squared. And 1/3 times minus 4/5 is minus 4/15 with an x, minus 15/5 x plus 20/5. And I'm going to do some reducing here. So let's see, I've got 1/5 x squared minus, maybe I don't want to, well, minus 4/15 x minus 3x plus 4, and then now I have to combine these here. So 1/5 x squared, and if you don't know what that is, right, if you don't know what that is, you can open your calculator and let it do the math for you. So here's my calculator, and I'm going to do negative 4/15 and then minus 3. And I get negative 49/15. Yikes. Glad I had my calculator. That's a lot of work. Negative 49/15 x plus 4. All right, now for the hard part, typing it into this answer space. So I'm going to use my DeltaMath keyboard this time. And I'm going to type 1 and then division sign 5 and then x squared minus 49 division sign 15 x and then plus 4. Whoops, don't want that. I want my x on the side of the fraction and I want my plus 4 at the end like that. Oh gosh. Let's see how we did. Did I get this right? Oh, please let me have gotten this right. Yes! Phew! Well, it wasn't so bad. All we did was FOIL these binomials, and we used our calculator really to do the hard work. So I think you could manage it, but you're going to want to have a calculator nearby, and if you don't have one, you can use the Desmos Scientific Online Calculator. That can do fractions for you as well. So let's try a new one. All right, 5/3 x times x. It gives me 5/3 x squared. 5/3 x times 3/5 is 15/15. Oh, not so bad. That's 1. 1/2 x and 3/10. Okay, so it looks like I'm going to get 5/3 x squared plus 1 and 1/2 x, right? This is going to be 1. And then plus 3/10. I wonder if we can enter it as a mixed number, or if we have to turn this back into 3/2. I don't know. You know what I'm going to do? I'm going to try entering it as a number and see what happens. So let me get this out of the way. Let's see. 5/3 arrow over x squared plus 1 and 1/2. Ooh, it gave me an 11. Wonder if I can... Oh, there we go. Okay, so it took a little extra keystrokes, but I was able to do it. 3/10. Ooh, let's see what happens. Oh, do not write your answer as a mixed number. Instead, write your answer as an improper fraction. Okay, so it's telling me no. So that means I need 3/2 here. All right. Let's see. 5/3 x squared, 3/2 x plus 3/10. Yes! All right, so now we know you cannot write a mixed number. You literally have to write it. So maybe what I would do here is I would just keep it 15/15 plus 1/2. I wonder if you're using this calculator, what would happen if you did that. 15/15. I know it's 1, but what would happen? Alpha y equals 1/2. Okay, there it is. Okay, so yeah, your calculator can give that to you. All right, I think you guys are kind of getting the hang of this. Just use a calculator to help you. All right, the third one is greatest common factor. So this is new for us this week. So we're looking for numbers and variables that we can divide each term here by, and whatever we divide by, we write that on the outside, and we write the remainder on the inside. So let's see how we do here. I believe 40 and 70 have a common factor of 10. Now they do not have any letters in common. So 10 is something I could divide these both by, and the remainder would be 4 minus 7x. And that's it. That's factoring. It's undistributing, right? So if I distribute this back, I should get the same answer, 40 minus 70x. Yes. So for us here, the answer is going to be 10 parentheses 4 minus 7x. Okay. All right, let's clear this screen out and try another one. 3x plus 7x squared. Okay, so for this question, I'm looking for a number that 3 and 7 have in common, and the only thing they have in common is a 1. And I don't need to divide by 1, so next I move on to the variables. Do they have any variables in common? Yes. Now this only has one single variable. Only has one single variable, so that's the highest amount I can divide by. And x divided by x would be just 3 left over. And then 7x squared divided by x, which means I subtract 2 x's, take away 1x, would give me 7 to an x to the power of 1. So take a, what did I mess up here? I wrote the wrong thing outside. I meant to write what I was dividing by, which is x. That's what's supposed to go out here. What are you dividing by? That is what you are factoring. So x on the outside, parentheses, 3 plus 7x. There we go. Awesome. All right, let's clear this screen and try again. All right, so for this one, I'm trying to think of a number that goes into 32 and 72. I'm pretty sure I know what it is. It's a single digit number, but here's what you would do if you didn't know, right? You just start guessing. You'd say, okay, 32 divided by 12. I don't know. Okay, that's not it. 32 divided by 8. Say, okay, there's 4 left over. And then 72 divided by 8, the same factor. And you get 9 left over. And then if 4 and 9 don't have any common factors, that's how you know you pulled out the greatest. See, like I could do this. 32 divided by 2 would work. And 72 divided by 2 would work. So they both would work. But you see how the factors left over are 16 and 36? Those are both even, so they can both be divided by 2. So that's how I know that 2 isn't the largest one. So I divided by 8. That worked for both of them. And 4 and 9 don't have any common factors. So that's how I know it's the greatest number that I can divide by. All right, so the greatest number I can divide by is 8. They do not both have x's, so 8 is my GCF. And I'm left with 4x squared plus 9. And that's it. That was a pretty fast one. 8 parentheses 4x shift 6 plus 9. Yay! Okay, new problem. Let's see if I can clear this out for a second. Let's see if I can find anything different looking. No, they all seem pretty basic. You either divide by a common number or you divide by a common letter. All right, so let me show you one of these again. Let's see if there's any that have both. No. All of these examples just have one thing in common. All right, so this one, all we have in common here is the variable x. So I pull out an x, but I'm left with 8 minus 3x. That's it. All right, so that is greatest common factor level 1. Oh, that makes sense. It's level 1. So you can only pull out one thing. All right, the second part is difference, or the fourth part, I should say, difference of perfect squares. All right, so remember, factoring, which is what we're going to be working on this week, is the opposite of distributing. Now, do you remember when we were distributing and we had sentences like this? And every time we foiled, right, every time we foiled, we got a repeat number in the middle. Remember that? We always got a repeat number in the middle. But when we had problems that looked like this, x plus 3 and x minus 3, x squared minus 3x plus 3x minus 9, we always got inverses in the middle. And it always resulted in a binomial answer instead of a trinomial. This is called a difference of two perfect squares. So anytime you have a binomial times almost itself, but the only difference is that one has a plus sign and one has a minus sign, and I don't even care what's here. It has to match, but it can be any number that we want. So I could have a 7. I could have a 17. I could have a 17/5, right? I could have anything as long as they're matching and you have one of each sign. So if I have a difference of two squares given to me already, then I know that it used to be a binomial that matched but had different signs. Now, how do I find these things? How do I know what's here and what's there? How do I know what that is? Well, it's very simple. You square root the first term, you square root the second term. That's it. Square root of x squared is x, so there's x in the first position. Make sure you have a plus and minus sign, and then you square root the second position number. So x plus 7, x minus 7. Awesome, let's try that again. Remember, if you have a difference, that means a minus sign, of two perfect squares, 121 is a perfect square, 144 is a perfect square, then you have two binomials, one with a plus sign and one with a minus sign, and you simply square root the first term, write it in both sections, square root the last term, write it in both sections. So our final answer here is parentheses 11x plus 12, parentheses 11x minus 12. Let's check it. Fantastic. So each time you're going to do the same thing, right? Square root the first, square root the last. Square root the first, square root the last. And each time you must have one with a plus sign, one with a minus sign. Square root the first, square root the last. That's it. All right, let's go on to the final section, the X game. All right, so this is going to help us with our trinomial factoring. So trinomial factoring requires you to understand what this diamond pattern or the X game is all about. And the X game requires you to find two mystery numbers, and those two mystery numbers have to have these things in common. They have to multiply to become a minus 18 or negative 18, but those same numbers also have to add to become negative 3. So I got to think of two numbers that multiply to 18. So 1 and 18, 1 and 18, 2 and 9, negative 2 and 9, 3 and negative 6, negative 3 and 6, right? So this is what's going on in my head right now. But then I have to pick the factors that would add to negative 3. And that would be this one. So the answers go here, 3 and negative 6. So 3 and negative 6 are the answers to this X game. So type in here 3, type in here negative 6. And you submit your answer. All right, let's try that again. Two numbers that multiply to 30, so 3 and 10, 2 and 15, 6 and 5, but they have to add to 13. So I'm thinking 3 and 10. Great. You get it? Two numbers that multiply to negative 12, so 1 and 12, 2 and 6, 3 and 4, and one of them has to be negative though, because the answer is negative 12. And if the answer is negative and the sum is negative, that means the bigger factor would have to be negative. So you have negative 1 and positive 12, positive 1 and negative 12, right? And then you've got negative 2 and 6, or 2 and negative 6. See how this makes negative 4, and the bigger number is the negative 1? That's always going to be true. So 2 and negative 6. All right, that completes the 5 lessons that are in homework number 9.